we will start now. Hello.
Hello. You can start.
Okay. Good afternoon, everyone. I welcome you all in this second section. Today we have a guest, Dr. Ramesh Lekurwale, sir. He is working as a head mechanical engineering department at KJ Somaiya College of Engineering, Mumbai. Sir has completed PhD in production engineering from VJTI Mumbai in 2015. Sir have completed MTech in mechanical engineering from IIT Bombay. He have total academic experience of 25 years and 1 year of industrial experience. So far, sir has published many research papers in international and national journals of repute, as well as in the national and international conferences. Sir also invited as a speaker by many institutions. I welcome you, sir, in this session, and I request Dr. Lekurwale, sir, to start his session.
Thank you, sir, for giving me the opportunity to share my views. Can you see my screen, everyone?
Yes.
Okay.
Yes, sir.
Yes, okay, sir. You can, so you can see the screen?
Yes.
Yes, sir. Okay. So, once again, thank you, KJ College of Engineering, giving me the opportunity to share my views. So today I will be talking about MCDM method. In the MCDM method specifically, I will be talking about the and its application. So the outline of my presentation is so first of all, I will give the brief introduction about the MCDM. Then various types, various methods of MCDM that we will discuss in brief. Then specifically we will go for the VIKOR method, which is nothing but the compromise ranking method. This method we will discuss in detail with the help of the case study, so that this particular method will be useful. This method will be useful for you for your research work, maybe project for MTech as well as the BTech. So the brief introduction about the MCDM is, it is nothing but the decision making method. This particular thing we'll talk about the considering the manufacturing environment. So I hope that everybody, even if it's not from the manufacturing environment, other people will be able to understand it, because I am going to conduct the very generalized case study. That case study will be able to understand each and every student, whether that particular student is from manufacturing background or maybe from other background. So just for the understanding, I am taking the example of the manufacturing environment. So because of the fast changing in the technology, decision makers in manufacturing sector frequently faces the problem in order to ascend the wide range of alternatives and okay. Sanjay sir. Hello. So because of fast changing technology, decision makers in manufacturing sector frequently faces the problem for assessing the wide range of alternative and selecting one of the best alternative among that, while all the criteria is very conflicting in order to meet the challenges in the manufacturing industries. All the criteria is very conflicting criteria, very confusing criteria, which is to be select, which is to be reject, and how much importance to given to which criteria. So all this is very conflicting. So that's, in order to choose the alternative, the decision maker have to take into account the large number of criteria and their sub criteria also. So I have listed some general criteria below this. You can read also. Technological criteria, then economic, as ethical, political, legal, and social factors. So these are very generalized factors that we need to consider while taking the decision for anything. Anything means whether it is a manufacturing or any other sector. Now, some of the important decision making situation I have listed below. This is typically as far as the manufacturing environment is concerned. Now, decision making means we have to select some, we have to reach to some optimum decision. So that is in case of selecting the appropriate manufacturing strategy. It may be in case of selecting the manufacturing processes. It may be selection of workpiece and the tool material, manufacturing equipment, material selection, evaluation of alternative product design, machinability of evaluation of work material, cutting fluid selection, robot selection, automated inspection system, material handling system, and so on and so forth. So I have listed very few. So there can be n number, and this is I have listed only for manufacturing environment. You can list from your specific environment, and you can use this particular method for this one. I hope that after attending the next lecture, you will be able to use that VIKOR for your specific problem. Now, so there is a need, since there are very conflicting criteria, there is need some simple systematic and logical method or mathematical tool to guide the decision maker in considering the number of selection criteria and their interrelation. So each criteria is having some interrelation with other. So the decision maker has to understand that, and accordingly he has to reach to the correct decision. The objective of this any decision making method is identify the appropriate selection of criteria and their combination. So first of all, the decision maker has to select which are the appropriate criteria that is going to be useful to reach to the correct decision and their internal combinations. That is the first one and very much important. Thus, effort need to identify the criteria that influence the selection of an alternative. Okay, so you have to identify which criteria is going to influence the alternative for a given particular problem. Okay, and that is again using some logical method. Then we have to eliminate the unsuitable alternative. Okay, then select the most appropriate alternative to strengthen the existing selection procedure. So this effort we need to do. Now, how we are going to do this? This is the MCDM technique will help you to achieve the particular decision. This MCDM technique presents such a simple, systematic and logical technique to reach the correct decision. MCDM means multi-criteria decision making. So in that there are some methods. Here I listed graph theory and matrix approach. Graph theory and matrix approach is nothing but it is handling inherent errors that can deal with the large number of qualitative as well as the quantitative attributes simultaneously. Then second method is the fuzzy multiple attribute decision making method. So our VIKOR criteria is coming under this fuzzy multiple attribute decision maker. Now, multiple attribute decision maker falls under the category of multiple decision criteria making method. Okay, decision maker in presence of multiple generally conflicting criteria. Now, MCDM, that is multi-criteria decision making, have two classifications. One is a MODM and other is a MADM. MODM means multiple objective decision making methods where large number of alternative choices are there. However, multiple attribute decision making method means where limited number of pre-specified alternatives are there. So our VIKOR comes under the specific alternative criteria. So we are going to focus on that. Now, MADM method has four main parts which forms the decision table. Also, we called as the decision matrix. That is nothing but alternative, attributes, weight, or again you can call it the relative importance of each attribute, measure of performance of the alternative with respect to the attributes. In the next table, you can get the idea of what exactly the decision table is. This decision table is nothing but it is also called as the decision matrix. Here on the left side, you can see alternative A1, A2, A3 up to AN. This is B1, B2, B3 up to BM, and this W1, W2 is nothing but the importance of this particular attribute. Then M11, M12, this is nothing but the performance of alternative A1 with respect to B1. So like that. So this is the decision matrix. This again we are going to discuss in detail when we discuss the case study. What is the meaning of this B1, B2? What is W1, W2? How to calculate that? How to reach to the correct alternative? All this is going to we are going to discuss in detail in the form of the case study. Then and only then you will be understood you will be able to understand the meaning of all this terminology what I am going to explaining now. Now, the commonly used decision making methods are SAW, that is simple additive methods, or it is also called as the weighted sum method, then weighted product method, then analytical hierarchy process, then technique for order preference by similarity to the IDCH, that is in short it is called as the TOPSIS, then VIKOR ranking method. We are going to discuss this VIKOR method in detail. Then VIKOR. So this is the full form of that. If anybody can pronounce properly, I think KK will give the certificate, 2 certificate to that particular person. So this is very pronunciation is difficult. So that's why we are calling it short in VIKOR. Next, VIKOR is nothing but it is a compromise ranking method. Now we'll see how the different steps that is used in the VIKOR. The compromise solution, using this VIKOR method, we are going to get the compromise solution that is closest to the ideal solution. In that, we have to find out, determine the best, that is Mij max, and determine the worst, that is Mij mean. So what is Mij max, Mij mean, what is best, what is worst, all this you'll be able to understand in the case study only. Then we have to calculate EI-FI. EI-FI is nothing, some value that is useful for finding out the PI, that is performance index here. Okay, EI. Now this is for beneficial attribute, this is for non-beneficial attribute. Now what is beneficial attribute and non-beneficial attribute? Now if you want to take any particular problem, and in that, suppose profit is there, profit is one of the attribute. Okay, now that profit is a beneficial attribute. Why beneficial attribute? We are going to select the maximum value of that. That's why it is called as a beneficial attribute. And for non-beneficial attribute, suppose the cost. Okay, if you are going to select any particular goal, and in that one of the criteria is a cost, then in that case the cost you are going to select least. So that is non-beneficial attribute. So this is the difference between the beneficial and non-beneficial attribute. Okay. Then what is this Mij mean, Mij max? This you will be able to understand detail with the help of the case study only. Then this Fi, this is the formula. In Fi you have to select the maximum value from this one. Okay. EI, okay. E1, E2, E3. Then you will get F1, F2, F3. The maximum value from this one. Okay. Then you have to calculate PI. PI nothing but the performance index. After calculating the performance index, you have to select the least value from the performance index. That is nothing but your final alternative for alternative of your choice. Now this PI is nothing but V EI minus E mean divided by E mean. This is the formula for that, 1 plus V and all that. Now in general, the value of VI is taken as 0.5. Okay, it can be 1 also, but in generally it is taken as 0.5. So this is the procedure that we are going to use to solve the problem of VIKOR. This is a very short procedure. Okay, at this time you may or may not be able to understand the various terminology, various terms which I listed over here. But when you start the case study, that time I hope that I hope as well as I'm sure everybody will be able to understand what exactly the method VIKOR is. Next, now see the simple case study. Okay, now see. We are having the 3 alternatives here, H1, H2, H3. We are having the 3 houses. Okay. Now, just take the example. Let us say I am a decision maker. Okay. I have to buy the house. And when I am going to buy the house, I am having the 3 alternatives. That is H1, house number 1, house number 2, house number 3. 3 alternatives I have selected. Okay. For example, suppose take the practical example. Suppose you want to buy a bike. Okay, then you will select some 3-4 companies, for example Bajaj, Honda, okay, then Kawasaki, Suzuki, all these ones. So these are nothing but your alternative. From that alternative, how you are going to select the best one? So this one. Now come to the case study of the house selection. Here, house number 1. Now these are the 3 alternatives. These are the 3 attributes. Price, near to the market and near to the school. Based on these 3 alternatives, I have to select the H1, H2, H3. Okay. Then this is price in lakhs. House number 1 is having the 10 lakh price and it is 1.5 kilometer from the market and it is 2.75 kilometer from the near to the school. House number 2, this is price is 14. Okay, near to the school 1 kilometer and near to the market it is 3.5. House number 3, 8, price is 8 and 1.7 and 3 kilometer from near to the school. Now these are my various criteria. Based on this criteria, I have to select the optimum value of house number 1, 2 or 3 which will satisfy this criteria to the optimum level. Okay, for example what you can do here, in general if you say everybody will think the list cost, that means 8. Everybody will see it should be near to the school, everybody will look near to the market, that is 1. So if I say price, I can select house number 3. If I say near to the market, I can select S2. If I say near to the school, I can select H1. So in this I am getting 3 different options, but I have to select only 1. So how to go ahead with that? Okay, that will satisfy the optimum value of all these this one attributes: price to the price, near to the market, and near to the school. Now, for that, what you have to do? We have to calculate the weights. Now, weight we calculated using the AHP, that is analytic hypothesis, and these are weight 1. W1 is 0.64, W2 is this one. How we have calculated this weight, that I am going to explain now in detail. After that, we have to calculate EI. Okay, and this one. Again, we are going to come back to this particular slide. Okay, so now next I will explain how to calculate the weight using AHP. Now see, analytic hypothesis process. Now this process has been invented by SETI in 1980. It is the simplest and widest method used. Each attribute is given a weight and the sum of the weight of all attributes has to be 1. And each alternative is assessed with regards to the attribute. Now overall weight is calculated using the method of geometric mean. Geometric mean is nothing but sum of product of j is equal to 1 to m bij to the power of 1 by m, and weight is calculated. It's a ratio of geometric mean divided by total mean. Now how calculated you can see in the next. Now first of all, what you have to do, this is nothing but the price. This is NM is near to the market, near to the school. Now we have to make the decision matrix that we have discussed in the beginning, decision matrix. Okay. Now we have to compare each attribute. Okay. Price to the near to the school, price to near to the market, price to the near to the school. Then this one. Each and every attribute we have to compare each other. How we can compare? Now this matrix, this decision matrix, this is purely the decision maker's job. Because suppose I am going to buy the house, my choice will be different. Suppose you are going to buy the house, your choice will be different. Okay. Now, according to my thinking, what I done, I have given I have prepared the decision matrix this way. Now, price to the this one, I have compared price with the near to the school attribute, and I have given the 5. So how I got this 5 is nothing but using this numerical scale. This is the verbal judgment. What I am thinking that as far as my goal is concerned, I have given I thought price is strongly important compared to the near to the school. Then I have given 0.3 over here. In that, the meaning of the 0.3 is nothing but it is moderately important compared to the price. Price is moderately important near to the school. However, it is strongly important near to the market. Now, this way I have to prepare this upper triangular matrix, and the diagonal matrix is always 1 because you are computing price to price, near to the market to near to the market, near to the school and near to. So that's why diagonal matrix is always 1. So this way you can prepare this upper triangular matrix, and lower triangular matrix is nothing but the reciprocal of that. You can see when you compare price to near to the market, and here near to the market to the price, it is 1 by 5. Okay, so that's way it is a reciprocal. Now this way you can prepare this matrix. Then here I have again written in detail matrix constructed using this scale. AHP scale, attribute is compared, an attribute compared with itself is always 1, so that is nothing but this diagonal matrix. Then this number 2, 4, 6, 8, this is the compromise. Now here the numerical scale given by the SATI is 1, 3, 5, 7. Now sometimes if you are thinking, if you are confused, if you are not very much sure whether to give the 2 point or 3 point or 5 point or 7 point, so suppose you are confused between 3 and 5, you can give 4. For example, here suppose you are not sure whether to give the 0.3 or 0.5, so you can give 0.4. So that is a compromise between these two. So 2, 4, 6, 8, it is a compromise between this value. So you can use that value also. So this way the decision matrix has been constructed. I hope that everybody is understanding. Anyone can just reply. Everybody is understanding? Hello? Okay. So I hope that everybody is understanding. We'll go to the next part.
लेकुरवाळे सर.
बोला सर.
हाँ एकदम व्यवस्थित चालू आहे.
चालू आहे ना?
हो गुड.
Okay. So this. Okay. So again in the next slide I have given the very detailed this one explanation of this. After reading this also you can able to understand what is the meaning of 5, what is the meaning of 3, what is the meaning of 1 by 5. If you read this one, P is considered strongly important than NM in house selection, and therefore the relative importance of 5 is assigned P over NS. Okay. P and over NS it is so here some this thing typo error is there. Okay. P over NM is 5 and P over NS is 3. Again, P is considered moderately important over NS. It is given. Okay, it is value 3 over here, and the reciprocal is 1 by 5. So here now again I am telling you again and again, the construction of decision matrix, it is the job of decision maker. Suppose you are decision maker, then you have to prepare this matrix. Suppose I am decision maker, I will prepare this matrix. Okay. Then after this, how to calculate the weight? Here the calculation of weight is nothing but the geometric mean. See, this is my decision matrix. Geometric mean is calculated. See here, 1:5 into 3. So that if you see the first row, 1:5:3, raised to the power 1 by 3. Why 1 by 3? Because the order of the matrix is 3. If the order of the matrix is 4, then this will be 1 by 4. That way the value you got 2 point this one. Then second row, this one, 1 by 5. Okay, this one. Then it is raised to the power 1 by 3, the value got. Then go to the third row, 1 by 3 into 2 into 1. See here, 1 by 3, 2 into 1, 2. Raised to the power 1 by 3, the value is 0.873. So this is GM1, GM2, GM3. That is geometric mean of first, second, third. Then grand geometric mean, that is total. Do the summation of all this, the summation comes to be this much. Then the relative normalized matrix, relative normalized weight, you can calculate it. Already I have shown, I have explained you the this thing formula, that is geometric mean of 1 divided by the grand geometric mean. So this is first one. This is 2.4666 divided by this total. So this way I got 0.64. Then the second one, 0.46 divided by 0.38. So this way I got the second. Then third one, 0.87 divided by the grand geometric mean. So this way I got. So this way I got the W1, W2, W3, which you have seen in the previous one. Now, whether it is W1, W2, W3, whether it is consistent or not, how you will come to know. Whether your decision is consistent or not, how you will come to know. Okay, because this is all based on the verbal judgment. I can think something else, you can think something, you can think something else, other can think something else. So we have to check the consistency. For that, here the consistency ratio we have to find out, and this consistency ratio has to be less than 0.1. Then and then you can say your decision is consistent. So for that, what you have to do? You have to do further calculation. A1, okay, and A2. This is the matrix. This is decision matrix, and this is the weight matrix. Here, calculate A3. A3 is nothing but A1 multiplied by A2. Multiply this 2, you will get A3. Then A4. A4 is nothing but A3 divided by A2. This is A3 matrix. This is A2 matrix. You will get A4. A4 you got. This is nothing but lambda 1, lambda 2, lambda 3. Calculate the average of that, lambda 1, lambda 1. So this is the average. Then CI, that is consistency index. Lambda average minus M. M is nothing but the order of the matrix. Okay. lambda average minus m divided by m minus 1. So m is nothing but the order of the matrix. Here order of the matrix is 3. So that's why lambda average minus 3 divided by 3 minus 1. So this I got Ci. After calculating Ci, I have to calculate Cr. Cr is nothing but consistency ratio. It is the ratio of Ci divided by Ri. What is Ri? It is a random index, and that random index you are having the standard values. Okay, for order 3, the standard value of random index is 0.52. This one. So like that, this random index value is available anywhere. You can take that. Depends upon the this one order of the matrix. This changes. Okay, so that way I got the consistency ratio 0.003, which is very less than 0.1. So my decisions are consistent. If suppose you got this CR 0.2, that means what you have to do, you have to revisit the decision matrix. You have to change this value till you get this consistency ratio of 0.1, less than 0.1. Okay, if you are getting less than 0.1 in the first shot only, then no issue. If you are not getting, then you have to revisit, you have to rethink, you have to change these values, and then again do the calculation. This calculation you can do very easily, either using the software. The name of the software is Expert. Expert is nothing but the name of the software, or you can make the simple Excel sheet to do all this calculation. Okay, if you make the sheet for 3 by 3 and change this value, immediately within a moment you will get this CR. You don't have to do all the calculation again. So this way you got this W1, W2, W3. Now we'll go back to the previous sheet. Here we have discussed this one. Then I told earlier the W1, W2, W3, this one, and then EI. Now how to calculate E1? See here E1. See, wait, here E1. You can see the formula over here. Summation J is equal to 1 to M Wi Mij minus Mij mean, Mij max minus M. Now, so this is EI, nothing but this E1. Okay, you have to calculate the value of E1, E2, E3. That means for house 1, house 2, house 3. So E1, it is 0.6483. This is E1 means this is nothing but a W1. You can see W1 this one. Okay, and this 10 is nothing but first value. Okay, that is M11, you can say. Then minus 8. What is minus 8? Mij mean. Why you have to take Mij mean? Because this is the price. Why? Price, and this is non-beneficial attribute. And for a non-beneficial attribute, we are selecting the least value. That's why Mij mean is this one. Okay. Then Mij max, 14 and MI. So this value, see, Mij max, Mij mean, this denominator is going to remain same for all. Okay. This one for first. Then second W2. What is W2? This one. Now you have to go for this. Now here 1.5 M11 minus 1 is this list value. Okay. Divided by 1.7 minus 1. So that is minimum maximum. Maximum minus minimum. Then third one, W3. W3 is this. Okay. Third value of this one. Minus. Okay. Again the list value is this. So Mij mean will come the same. Then 3.5 maximum value. Mij max. Mij mean is 2.5. 2.75. So this way you have to substitute this value in this formula. Formula is given over here. I have explained the value, how to calculate, how to enter that value in that respective field. So this way you have completed E1. E1 for the first one, house H1. Now you can see the first term value here. This one is 0.2161, 0.81, and this is 0. Same way you can calculate for the E2. E2 is 0.6483. Okay, W1. Okay, then this one E2, the second value you have to take. Mij is this value you have to take. Okay, that means you are calculating for the second house. So that's why you have to take the second. Then Mij mean, that is going to remain same. Mij max, Mij mean for the first row, for the first column, second column, and third column. That is going to remain same. We are going column wise. Okay. Then W2. W2 for the second column. Here, the second value is 1 and again the list value is also 1. So that's why the value of this will be 0. Then third one here. So 0.2296, 0.35, this is the second value, and then the minimum value. Then Mij max, Mij min, the denominator will remain same. Okay. So after calculation I got 0.6483. Okay. For this one of the term out of the 3 will be 0 always. Okay. Then this one 0.2296, after calculation I got this. Okay, because this is denominator and numerator is same. Numerator is same, so I am getting the same value. So this way you have calculated E2. Then E3. E3 0.648. So this one, third value. Okay. Okay. This one. This is 8. So W1 is this. Then Mij means M13 here. The third one, third value. This one. Again Mij mean is 8. Same value. So this will be 0. Then second W2. Okay. Then the third value from the second row, second column is this 1.7 minus 1. Then the third column. Okay. Third value from the third column 3. Okay. So this way you got now after calculation you got E3 is this is going to 0 because 8 minus 1. Again this is numerator denominator same, the same value is going to come. So this way you got E1, E2, E3. This is nothing but some value to calculate performance index for house number 1, house number 2, house number 3, where all the criteria has been considered. That means for house 1 also you have considered PC, house 2 also you have considered PC, this one near to the market, then near to the school. For each and every alternative we have considered all the criteria simultaneously. That's why we have to calculate this E1, E2, E3 value. Then again I have copy pasted the same value E1, E2, E3 over here. You can see this color combination which I done over here, that will be able to understand you the values. This E1, this see here E1, E2, E3, this value I have copy pasted as it is from the previous slide, nothing more than that. Okay. Now here do the summation of this one. After summation you can find out the EI mean, EI mix, that max. That is useful for you to calculate the that value is going to use to calculate your PI, that is performance index. Now EI mean the least value of this all these three values, that is 0.91. EI max is 0.81. So this way you got EI mean and EI max that we need to use in the PI formula. Next, now you have to calculate FI. FI is nothing but the maximum of this EI value. Okay, see here, this is your E1, E2, E3. What is the maximum of this one? 0.61, 0.2161. That is nothing but my F1. Now to calculate F2, I have to select the maximum value from this E2. So that is 0.643. You can see here 0.643. Then E3, which is the maximum value of this E3 equation, that is 0.12. So this way you can calculate. No need to calculate, it is already calculated. You have to just pick up the value from this E1, E2, E3 maximum value. So that way you will get the value of F1, F2, F3. So using this formula just I copy pasted for your information, but you can just take the value. You can see this green color and this green color. It will be very easy to understand. You can match this violet color. You can match this red color. You will be able to understand you will be able to pick up the different values for the respective term. Okay, I hope that this is your understanding this very clearly. Then you have to calculate the PI. PI is nothing but the performance index. The formula is V EI. EI means E1. Suppose you have to calculate for P1, EI is E1, and EI minimum is nothing but this value. EI maximum is nothing but this value. EI minimum is same thing. 1 minus V. Fi. When you are calculating P1, that means performance index for house 1. Okay. Then you have to substitute F1. F1 is nothing but this value. F minimum is same. Then F maximum is same. F maximum value, which is the maximum value over here, I think 0.64. Minimum is, I think 0.12. Okay. So this way you can pick up the value, whatever you have calculated over here. Then P2. Now see, P2, V value I told you, V is the general value, okay, that you can take from 0.5 to 1. So I have taken 0.5. Okay. Now 0.5. EI, nothing but this E1 when you are calculating for 1. So this value I substituted. Okay. E mean is same here. Okay. E max is this value. E mean is this value. Okay. Then 1 minus 0.5. Then F1 is 0.2161. Okay. Mean value of this, minimum value of this one is 0.12. Then F max, that is F1. Okay. F max, that is this one, 0.648, and F minimum is this one. Okay. Now, when you calculate the P2, only the values which is written in the red color, that will change. The rest of the value will remain same, because minimum value of E and maximum value of E is not going to change. Minimum value of F and maximum value of F not going to change. So that's why when you calculate P2, only you have to think about the values which is in the red color. That means you have to substitute the value of E2, you have to substitute the value of F2, rest of the value will remain same. You can see here also, okay, all these values are same except this red color. Now for P2, you have to substitute E2 and you have to substitute F2. That's it, nothing. Okay, and all other the values given in the black color is not going to change at all, because it is a minimum and maximum value for EI and FI. Next, P3, in P3 also same, you have to substitute E3, you have to substitute F3, that's it. All other values going to same. One thing you have to note here, P1, P2, P3 or P1, one of the value is going to be 0. Then here, I have done the summation of this one, P1, I have written over here. Then summation of this P2, individual summation, I got P2 equal to 1. Then P3, I got P3 is equal to 0. Now this P1, P2, P3 is nothing but the performance index of house 1, house 2, house 3. Now you got P1, P2, P3 performance index, which you have calculated after considering all the criteria simultaneously. You have considered all the criteria, that is price as well as near to the market and near to the school simultaneously. After considering all that criteria simultaneously, you got the value, you got this performance index P1, P2, P3. Now you can reach to your decision by arranging the PI in the ascending order. That is P3 is 0, P1 is 0.1 and P2 is 1. After arranging this in the ascending order, best alternative is nothing but the least value of PI is the best alternative, which you are the best alternative considering all the possible value of your attribute to the maximum or to the optimum level. Now optimum level means the price I have considered the list, again near to the school list, near to the market list distance, but in all the cases it is not possible list somewhere or the other you have to compromise. So considering all that optimum value, your best alternative is ranking. Best alternative is house 3. In the house 3 you are going to consider all the values to the best possible way. So this way the ranking, according to this method, my ranking, I have to select house number 3 where I am going to satisfy all the attribute to the optimum level. So again I told you this visual where the value of that V is taken as 0.5. So this way I have concluded my session on VIKOR. I have explained the ASP also. I explained this method with the help of the case study. Now the forum is open for the question and answer. And if you want, I will explain again the AHP also, because AHP we have explained very short just for finding out the weights. Thank you, sir. Now the question answer, please. I think we are 10 to 15 minutes, 10 to 15 minutes for the question answer. Participant can answer the question, can ask the question.
Thank you, sir.
Yeah.
Lekurwale, sir. Thank you.
Sir, ask the participant to for the questions.
Sangre, sir.
Sangre,
Hello.
sir.
Sangre, sir. Sangre, sir. Hello.
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 Sangre, sir.
Participants can ask the question. They can raise the hands. Sangre sir will unmute him.
Sangre, sir. Any questions from audience?
I think audience are understood everything or confused everything. I don't. Sangre, sir, please encourage the participant to ask the question. I think we have finished well in time. We are giving 10 minutes to ask the questions also. नुसतं आपलं पटपट समजून पण एक्सप्लेन करून पण फायदा नाही ना. Participant should get some time. Accordingly, I have plan.
I think everything is understood by
or they have just
kept
their login on and they have moved somewhere else.
Hello.
Sangre sir, ask the participant.
Sir.
Okay. Hello. Am I audible, sir? No.
Sangre sir.
Yes, sir. Yes, sir. Hello. Hello.
Yeah.
Bola.
Okay, sir. There is one question from Omkar Kulkarni.
Okay.
How the value of V
request the participant to ask the questions.
Pardon?
How the value of V will affect the solution?
See, it doesn't affect the solution because the value of V is fixed, na? Accordingly, it is the multiplying factor. It is the multiplying factor. Whether you take the value of V 0.5, 0.6 or 1, it is changing the P1, P2, P3 uniformly, na? It is a multiplying factor for this one. And it is going to add or subtract in everywhere. But value of V should be same. You cannot take value of V for P1 0.5 and P2 0.7 and P3 0.8. It is not like that. You have to take the same value for that particular case study. For one case study, value of V will be same. That's it.
Okay. Sir, there is another question from Thakkar. What is the best alternative for AHP? I have got a review that AHP should be avoided.
See, as far as AHP is concerned, in AHP, we have to select the maximum value of this alternative. Okay, whatever the performance index is coming, from that, you have to select the maximum value. However, in case of the VIKOR, you have to select the minimum value of that. I think I have answered the question or no? Participant, please reply.
Sir, they can't reply.
Okay. So you just ask on this one chat.
Okay. Next question is the outcome of PHP is a weight and has to be followed by the method like VIKOR.
Yeah. See, the weight you can find out by weight you can calculate by any method, whether it is a HP or SAW or maybe this one WPM. Any weight you can calculate using any method. It's not like that only HP should be used for calculating the weights. Why I use the AHP? Because in AHP, one more step is there to calculate the consistency ratio. Using that, with the value of that consistency ratio, we'll come to know whether our decision is consistent or not. Okay, that means there is a double check when you calculate the value using the weight. So that's why I use the AHP. You can use the SAW, you can use other method also. Okay.
Okay. Next question is from Deepak Mahajan. Do we need another method for comparing the result with that of VIKOR?
You can definitely take the another method. Okay, when you use the other method, you will come to know whether your decision is correct or not. For cross-checking, you can definitely use that other method also. Any topsies or any other method.
Okay. Next question from Gaurav Kumar. What if we don't consider V for entire calculation? What is the significance of V?
V?
Yes.
V, na? Sir,
Yes,
this is the standard formula. Okay, this is the standard formula. This is calculated. This is given by the researcher. So he might have done lot many research on that, and based on that only he has given that formula. So we cannot challenge that. We are using as it is the formula, nothing more than that.
Okay. Next question is from Kailash Bhosle. What are the limitations of VIKOR?
What are the
limitations of VIKOR?
So as such, I don't find any limitation for this one.
Okay.
Only difference is here we have to select the list value of the performance index, and for other method we have to select the maximum value. This is the basic difference between the VIKOR and other method.
Next question from Suchita Lokhande. Can we apply HP for 10 alternative, means 10 by 10 matrix?
You can definitely, but see, when you go for the more alternative or maybe the attribute, what will happen? You need to check the consistency ratio, and second thing, we have to use the software. Okay, but as far as possible, when the alternatives are more, you need to check the consistency ratio, and consistency ratio has to be less than 0.1, and the software has to be.
Next question is, which is the recent tool of MCDM?
Which is the
recent tool of a MCDM?
Recent tool, this only, VIKOR, Topsy, and Promethi. These are all the recent methods that is used in MCDM.
Which software could be used for MCDM methods? Any tools?
Expert. Name of the software is Expert.
Expert.
EXPERT, Expert. Or again, the one software is there, Decision Science or Decision Tool. I don't exactly remember the name of that. Decision Tool or Decision Science, one software is there, and the Expert is also very widely used. Okay. Or simply you can make this one Excel sheet also. If you make the Excel sheet for a for a specific number of this one order of matrix. For order of matrix 3, you make one sheet. Order of matrix 4, you make another sheet. So like that, if you make 3-4 sheets up to 10 order, so you can use that sheet regularly. No need of software also in that case.
Next question is from for more alternative than 10 in ESP, it is not advisable.
Correct. So in that case, what you can do the cluster of the alternative.
Okay, cluster.
You can do the cluster of the alternative. A cluster of the alternative attributes. Cluster of the attributes you can do.
Can we get? Can we go for the fuzzy topsies?
Fuzzy topsies also you can go.
Next question is name of the softwares is the Decision Science and Expert. Are they free to use?
See, the Decision Science, exactly I don't know the name, Decision Science, but Expert is very clear. Name of the software is Expert only. It is free. Okay. Expert is free. You can download from the net. Any more?
Oh. Next, one suggestion from Rajan's ma'am, I think, Neela Rajan. A proper hierarchy will be rarely have more than 10 factors. Also, comparing 10 factors is not correct.
See, it is very clear. If you go for, if the number of factors increases, the accuracy level we need to check.
Okay. Okay, there are many feedbacks, sir. Feedback from participants. Thank you for useful information.
Okay.
Thank you for the session.
Okay.
So I also thank you, sir, for your wonderful session.
Okay.
Okay. Thank you so much, sir.
Okay. Thank you.
We will meet tomorrow at 11 a.m. for the next session.
Okay. Can I stop now?
Yes, yes. Thank you for all participants for joining the session.
Okay. So I will exit the meeting.